over energy practice exam reader. It's one of the very first chapter, thermochemistry. I just felt like we might need some review on the terms. So it's a good, since anyway we have enthalpy in chapter 16, so why not? But that's a good one to review. Number one, what is state function? I think that's something cool because only in this chapter we differentiate this by capitalized one. Okay, the capitalized one are, so we have delta H, S, delta G, temperature, pressure, we have a lot. What is this? Oh, there is an internal energy, U. We have more if you find, but I think that's one of the cool things of this chapter, which is it actually be differentiated by if the letter is capitalized or not. Okay, so what is not? Not state function, Q, heat, or W for work. These two are not. Alright, who is this? Okay, next one. What type of energy, what type of system would result in internal energy to be consistent? The internal energy is the total sum of Q and W. So it's isolated system. Ooh, okay, isolated.
Is it the same as closed?
Okay, good question. Open system, closed system. Closed system is just means the system is closed. Do you remember the first demo I did in this whole quarter? My hand was warming up the glassware, right? The heat can still transfer. Okay, isolated system. Heat, like this is not. It's like even heat cannot come in. Are we with this? So think about the first demo I did in the class. I was using my hand warming up a glass and then liquid go up. Remember that one? If it's an isolated system, I can put my hands around the glassware. The heat from my hand will not be able to warm up the liquid inside. That's isolated.
So like the bond layer?
Yeah. Cool. Okay. Number 3, consider the first law when what term is often negligible. When delta H is approximately equals to delta U. So I did this. It's kind of like in the way of my lecture notes. What is this? P delta V. Oh, actually it's right here.
It's TP?
Yeah, it's work. Work is P delta V. Yeah. I cross it out. Okay, we said delta U is the sum of Q and W. When we have bond calorimeter, we assume there negligibly amount of the volume change, which means you have a bond inside your calorimeter. We assume there are no volume change. It's just temperature change. Okay, so this one will be work. Okay, what type of system allows energy transfer across the boundary but not mass transfer? We just did it. Closed system. Ooh, okay. Closed. It's the second one. It's a Q, which is my demo. My hand can warm up the liquid inside the glassware, but whatever inside the liquid cannot really go out. There's no mass transfer, but only heat transfer. Okay, number 5. What type of function is independent of path? Okay, state function, which we just did. What type of, number 6, what type of function depends only on the current state that makes the pathway irrelevant? As long as it's irrelevant state. Okay? So number 5 and number 6 is kind of like a tricky in how they ask. But keep in mind, whatever a function, I don't care how you get to the stage. Think about our first, okay, if you are coming from here to here, I don't care if you like going Okay, I can go one more, okay. I don't care if you go here and come back, or if you go stage 1 and do a second stage, I don't care. As long as you ultimately from here goes to here, you should have the same amount, right? Okay, that's what I was referring to. For this delta H or something, it's like I don't really care how you get, as long as my initial state and final state for state function is the same. They should have the same amount of energy gap in between. You can go farther away and come back, but as long as it's the same initial and final state, then they should have the same amount of energy in between. Okay. Okay. Next one. Quantity of the heat exchange between a system and surrounding. It's called heat of the reaction. Okay. Okay, heat at constant pressure. Okay, my question is, bomb calorimeter, coffee cup calorimeter, who has the heat change at constant pressure? Coffee cup? Why? Because you did coffee cup lab in under room temperature, room atmosphere, right? Okay. Or in other way, coffee cup is something open system. Your pressure when you have a coffee cup, whatever P, which is atmosphere, is the same over the time, right? Okay. What is this one says? QP equals to delta H. Okay, heat at a constant pressure, QP, heat at a constant pressure is called anthem. That's why I said the only hard one is number 8. Okay. How about the other one? Constant volume. Well, it's a different one. Yeah, we just did. Okay. So far so good.